Welcome to the HVAC workshop. We're going to look at two different ways of heating a home. We're going to look at forced air furnaces and we're going to look at hydronic boilers. This is a 70% efficient forced air furnace. Now we'll remember from our HVAC unit that a forced air system has two sides. It has a supply side and a return side. Our cycle begins at the top of our furnace where it supplies hot air to the rest of the house through our supply ductwork. Then cold air from the house returns through return ductwork to the bottom of our furnace where it gets sucked in by the blower and the whole cycle begins again. On this furnace, the supply side is on the top side of the furnace. So the ductwork that supplies heat to the rest of the house, that's called the trunk line. It would go up here. Connecting to the trunk line, we have a plenum. That plenum then connects to the top of the AC coil, and the AC coil then sits right on top of our furnace. Inside of our furnace, we have a couple of heat exchangers. And if we look down in between these heat exchangers, we see a probe sticking out. We're going to talk about that in a minute. Over here, we have what's called the draft diverter. On top of the draft diverter is where our flue pipe would attach. If we look up underneath our draft diverter, we see the inside of our heat exchangers. So the way this works is the flue gases come up through the heat exchanger, come out through these holes into the draft diverter, and then out through the flue pipe. Now before the draft diverter, if the flue gases were not hot enough to overcome the cold air from outside, that cold air would come down the flue pipe, go into the heat exchangers, and blow the flame out of the unit, burning the house down. Some brilliant engineer came up with this concept of the draft diverter. So now, when those flue gases aren't hot enough, the cold air comes down the flue pipe. Instead of going into the heat exchangers, it comes down, bounces off of our draft diverter, and is diverted away from the flame of the furnace. Underneath the draft diverter is one of the places that you would check for a cracked heat exchanger. Down below the draft diverter, we have this silver dial. That dial is called the fan limit switch. What happens is when the furnace gets a call for heat, it turns on the burners. Those burners then begin to warm the heat exchangers. That little probe in between the heat exchangers is connected to that silver dial. So as the heat exchangers begin to heat up, that silver dial begins to turn. Once that dial turns far enough, it hits the fan switch. And so the fan switch then turns the blower on, blowing air across the heat exchangers, extracting heat out of the combustion gases. Now, if those heat exchangers continue to heat up, that dial will continue to turn until it hits the limit switch. When it hits the limit switch, it turns the gas off, and we continue to blow air across the heat exchanger, extracting heat out of the exchangers. The dial begins to turn back. Once it hits the limit switch, if there's still a call for heat, we turn the gas back on. If there's not, it continues to turn as the blower blows air across the heat exchangers, extracting the maximum amount of heat out of the existing combustion gases. Below that fan limit switch, we have our gas valve. Below the gas valve are the burners. If we look at the burners, we see that they actually go into the bottom side of the heat exchanger. So when the gas is burning, the warm combustion gases are going into the bottom of the heat exchanger, making their way up through the heat exchangers. The blower is blowing air across the heat exchangers, extracting the heat out of those combustion gases, and then they exit the heat exchanger at our draft diverter and make their way up the flue pipe. If we look back up in here, we can see one of the features of a 70% furnace. This is the pilot light. Down below our burners, we have our squirrel cage or blower. Inside our blower is our blower motor. This is a direct drive blower, so the motor is inside the squirrel cage. If we were indirect, then the motor would be outside the squirrel cage and attached by a belt. Right outside our blower motor is where our filter goes, and then our return ducting attaches to the furnace right here. When we're in the field, one way that we can determine furnace efficiency is by looking at the nameplate. On the nameplate, we'll find BTUs in and BTUs out. This nameplate has 80,000 BTUs in and 64,000 BTUs out. If we do a little bit of math, we'll actually calculate that that's 80% efficiency. But we have to keep in mind that this furnace has a standing pilot light that uses gas all year round that we don't get any heat out of. That's why we label these 70% efficient. This is an 80% efficient furnace. In a lot of ways, it works like the 70% efficient furnace in that we extract heat out of the combustion gas through the heat exchangers, then supply that heat to the house out of the top of the furnace through the supply ductworking. Then the cold air returns to the furnace at the bottom. Some of the differences are this machine doesn't have a draft diverter. Instead, we have a draft-inducing fan. What that fan does is it helps the combustion gas draft up the flue pipe and out of the house. That allows us to extract more heat out of the combustion gas than we can out of the 70% furnace. This is the high and low pressure switch. They make sure that the draft-inducing fan is operating properly. These are the gas valves. Gas comes out here, goes through the orifice, then we have a flame on the other side that goes into the heat exchangers. If we look at the heat exchangers in the 80% efficient furnace, we notice that there's a serpentine pattern. That forces the combustion gases to spend more time in the heat exchanger, allowing us to extract more heat out of those combustion gases. And that adds to the efficiency of this furnace. So this is our gas valve. It's electronically controlled and doesn't have a standing pilot light. Another difference is that we don't have a fan limit switch. We actually have a computer control system. So when this unit gets a call for heat, it first turns on the draft-inducing fan. That vacuum in the heat exchanger evacuates any combustible gas that may be hanging around in there. Then our computer board senses the amount of draft that that fan is creating. If that board is sensing enough draft, then it turns on the hot surface igniter. Then it turns on the gas, giving us a flame. It monitors electronically the temperature of the heat exchangers. And when the heat exchangers get warm enough, then it turns on the blower and starts blowing air across the heat exchanger and out into the rest of the house. So right under the brain, we have the blower and the blower motor, and it sits on top of the return, and so we'd have our air filter right underneath. Now let's talk about what makes a 90+% efficient furnace unique. First thing you'll notice is that it has two PVC pipes attached to it. One brings combustion air from outside for the furnace to burn. The other takes our flue gases out of the building. We can use PVC pipe because we've extracted so much heat from the combustion gas that it won't melt the PVC pipe. We do that with a couple of unique features. First, we put the burners high and use our draft-inducing fan to pull those combustion gases down through our heat exchanger. So as the gases naturally want to rise, we pull them back down, making those combustion gases spend more time in the heat exchanger. The problem is that combustion gas also has water in it. So as that combustion gas begins to cool, the water begins to condense. And that water is a little bit acidic. So now we have to change materials so that we don't rust our heat exchanger. That secondary heat exchanger continues to pull heat out of the combustion gas. And then we exhaust that cool combustion gas out through our PVC pipe. That does another thing for us. In a 70% or an 80% furnace, the hottest part of the heat exchanger is down low where the coolest air is running across it. So as that air rises across the heat exchanger, the difference in temperature gets smaller. But on a 70% furnace, the hottest part of the heat exchanger is at the top and the coolest is at the bottom. So we have a nice, even temperature differential all the way across the heat exchanger. With a 90%er, we also have sealed combustion. If we look at a 70% unit or an 80% unit, we can actually reach in and touch the flame. These units are designed that way because they use conditioned air in the combustion process. In a 90%, that combustion air comes from outside. This makes the unit more efficient because we're not using conditioned air and exhausting it out of the flue pipe. This is an evaporator coil from a split system air conditioner. You'll find these on top of furnaces or sometimes in standalone units. We're looking at the top of it. Installed, warm air would blow from the backside through toward us. The high pressure vapor would come in the liquid line into the evaporator coils, cooling them. And as the warm air from the house blows across these evaporator fins, it would give up its heat, giving us nice cool air to the rest of the house. Then the warm liquid comes out of the low pressure line and goes back to the condenser unit.
Now this part of the course is the sheet metal. Okay. Now this right here, this is the supply duct. Supply ducts are usually bigger than this, but this is just supply duct. It can come in 14 by 8, 20 by 8, 12 by 8. And what I'm going to do is I'm going to cut a hole in here, and I'm going to connect some other ductwork up and show you how your supply duct, the ductwork, is coming off of your supply. And this right here, this is a hole cutter, and this will cut. I got it set for a 6-inch hole, so it will cut 6 inches. And first, we got to get a pilot hole and put that in there, and then drill another hole. So, time it didn't go all the way, so we take our snips and we just cut the hole here. And there we have a circle. Dangerous weapon, don't use it. And this here is a collar that we're going to put right in here. Now the collar has these little tabs on it that once I put it in here, then I have to bend the tab back so it can hold up against the metal. Now, you got to wear gloves with these and be careful because you'll cut yourself, and I don't know anybody that hasn't cut themselves, including me, okay? So, and then also wear your safety glasses too, okay? Now, we have a piece here that is 6-inch duct, and what I'm going to do is I'm going to fold it over. I'm going to connect it. That piece there. And now, and you heard it click together, so which means that it is secured. That's what we want. Sometimes we get the edges, they're not cut all the way exactly like we should, so we take our snips and cut them. And so we have our 6-inch round duct. Now what we want to do here is we want to get a crimp similar to this. Okay. And so these are called crimpers, and You're holding, the best way to do it is just hold this in your hand and crimp it. And sometimes what this does also for your hands is strengthen your hands. So you go to shake somebody's hand and you break it off almost. You know? What I'm gonna do here, get it to fit on there. And also, we're going to have to put some screws in it. And one thing that you do have to make sure is when you put in duct work is that it is secure. Secure in places that instead of just thinking, oh, well, I done it, that's enough, that's all I need. No, because if you don't, I guarantee you, you're gonna be back. And you don't want to come back to the job, okay, especially after you got paid. And so you add about at least 3 screws. And then if you can get at it, add 4, but do at least 3 screws. What we have here, we got another piece. I'm gonna cut another piece, and we're gonna put it on here, extend it. Just put this together. And you got to get it to the point that you hear it snap. You hear it crimp snap. Okay. And so now what we're going to do here, we can put this right there. This is really, after you've done so many of them, it's really not hard to do sheet metal. That's the thing I do, I say. And so then this one, your register would go to here. Now also what we have is, we have some mastic. Remember I showed you how you seal the ducts together and what is sealed? And this is mastic. In the real world, we call it pookie. Pookie. Because it's very sticky, it gets on your hands. And so what we do is we seal it around here.
So you just use that mastic, not with tape?
Not with tape, no.
But you can't put it over tape if there's already tape.
Can I, if it's already taped, put it over tape? I would say take the tape off and put this on there. And so what we have here, that's the way it looks. That's the way.
How long would it take to dry?
Oh, it'll be dry probably about an hour or so, maybe a couple of hours. We don't worry about it. We just throw it on there and keep rolling. Keep going, keep working. Yeah, yeah. Okay, and that's what the return duct will look like. If you wanted it in this room right here and it was hanging up, this is what we do. And it'll be longer, and then you'll have a register at the end. You'd have a 6-inch register at the end. No, you got to make sure that you get these crimps going towards the airflow. If you turn it back the other way, then you're going to get leaks.
Okay.
You want to, and then you'll get some whistling sound too. Okay, so you want the crimps, you want the air is coming in here, all my crimps was going out toward the supply. That's what you want. Okay.
Does it matter how close the first vent is off the furnace?
Yeah, you can't, like some people may come,
Pressure or?
yes, static pressure. Like if this is the end right here, I wouldn't tap in here. You got to go at least a foot above. It's kind of a rule of thumb, the foot. Don't just come right here at the beginning of it and tap off of there because you're taking the majority of the air from it. So I would say we have a foot rule or more to tap into it. Well, we can buy rolls of insulation, like say for instance 6-inch, and I can roll my insulation all up on here. Okay, and that's what we do. And then
Just fiberglass, or what's the insulation made out of?
Fiberglass just comes in a spring and a roll. Yeah, we can roll it on there. It's good to use insulation, good to insulate any pipes that you can see up underneath the house in the attic, and it's not insulation, then it's heat related, HVAC related, energy related. Go ahead and insulate them up. Suggest to the customers to do that.